Hello and welcome to the GCSE Science Tutor. Today we're looking at Lesson 2, Filtration and Crystallisation. But before we begin, let's recap what we did last lesson on elements and compounds. So here's a little task. Air is a mixture of compounds and elements. Draw a particle diagram to show this. Air contains oxygen gas, O2, carbon dioxide, CO2, argon, Ar, and nitrogen, N2. As an extension task, you could label your diagram with whether they are elements or compounds and give reasons for your answers. Pause the video now and I will go through the answer on the next slide. So let's first draw oxygen. Oxygen has the formula O2. This means that there are two oxygen atoms bonded together. Both oxygen atoms are of the same type of element, they are oxygen, so therefore this is an element. Oxygen also forms a molecule because there is more than one atom present. Let's also have a look at carbon dioxide. Carbon dioxide consists of two oxygen atoms bonded to a carbon atom. Carbon dioxide, with the formula CO2, would be a compound. A compound because there is more than one type of atom present. There is both carbon and oxygen. It would also be a molecule because you have more than one atom there. Let's take a look at argon. Argon has the formulae Ar and is just represented by a single atom. This would also be an element because it is the same type of atom. There's only one atom, it cannot be a molecule. And nitrogen is very similar to oxygen. It has the formulae N2, two nitrogen atoms bonded together, so therefore it is an element. So today we're going to focus on separating mixtures, and our first example is going to be a mixture of sand, salt and water. So let's first represent this as a particle diagram. Water has the formulae H2O, which consists of two hydrogens and one oxygen atom. So we can represent it like this. Salt is also known as sodium chloride, which has the formulae NaCl and consists of a single sodium and chlorine atom. And we can draw it like this: a sodium atom and a chlorine atom bonded together. Sand has the chemical formulae silicon dioxide and consists of two oxygen atoms bonded to a silicon atom, like so. Now we can see here that we have a mixture of compounds. All of these are compounds because they are made up of more than one type of atom. It is a mixture because these compounds are not all joined together. The compounds are in fact separate. And as we saw in our previous lesson, we can separate compounds and elements too through physical means. So let's look at some characteristics of these chemicals. Sand is insoluble. That means it does not dissolve in water. Salt, however, is soluble and will dissolve. Now, before we look at the process of separating these compounds, let's make sure we know the name of these apparatus. Pause the video now and try to have a guess at what their names are. We have a conical flask, filter paper, tripod, a funnel, a gauze, a Bunsen burner, an evaporating dish or basin, a beaker, and a stirring rod. Here's a demonstration of separating the salt and the sand using the apparatus that we discussed before. The sand is getting mixed with the salt alongside some water. The sand is insoluble, which means that it does not dissolve in the water and stays suspended within the liquid. The salt is soluble and does dissolve in the water. Fold the filter paper into 4 quarters, place it into the funnel, pour the mixture through the filter paper where the sand is going to be too large and will get caught in the paper to form the residue, and the salty water solution will pass through to form the filtrate. The filtrate, the salty water, is then poured into a beaker where it is then heated for the water to evaporate in order to leave the salt behind as a solid. There is, however, an issue that occurs when you directly heat a salt solution with a Bunsen burner flame. So I'm going to show you an alternative method which produces much better crystals. So here on the left we have the crystallizing basin or crystallizing dish sat over a water bath, whereas on the right we are showing the crystallizing process through direct heating, and there is a difference. This time, rather than using a sodium chloride solution, they're using this lovely blue-coloured copper sulfate solution. So once again, we're directly heating the salt solution to evaporate the water, but this is through direct heating, which is where you keep heating until all the water is evaporated to dryness. This causes spitting of crystals to occur and the breakdown of the crystals to produce an anhydrous crystal, which looks a bit like a white powder and is not a crystal. So this is not the method we use in order to produce crystals. However, when we place the salt solution in a crystallizing basin, which is sat over a water bath, we can gently evaporate the water until a saturated solution is obtained. After several hours, you will notice that the crystals have not broken down and we are left with some large, clearly very crystalline chemicals produced. And they look very, very different to the substance produced in the previous experiment. In an exam, you are likely to be asked how to describe and explain the separation methods of filtration and crystallization. So for both of those, have a go at drawing a labeled diagram of the apparatus used and explain how this works using the keywords on the right. Remember, when drawing apparatus in science, there is no need to draw 3D diagrams. Simply use a ruler and keep your diagram simple and use 2D diagrams instead. Pause the video now and I will go through the answers on the next slide. Notice when drawing the apparatus, I've kept everything very, very simple. However, what I have omitted at the moment are some labels. So let's add them in now. So up here I have my beaker. I have my sand salt mixture being poured into my funnel. My sand is getting caught in the filter paper. The substance that does not pass through the filter paper because it is too large is given the name residue. And the salt solution which passed through, we call that the filtrate. And we tend to collect it inside a conical flask where the neck of the flask is small enough in order for the funnel to sit in suitably up here. A suitable explanation would look something like this. The insoluble sand does not dissolve in the water and is trapped in the filter paper, forming the residue. The soluble salt dissolves in the water, forming a salt solution, and passes through the filter paper, forming the filtrate. Similarly, for crystallization, I have drawn a very simple 2D diagram, but it's really important that we add our labels. So, as discussed, it was very important that we heat and crystallize the salt over a water bath. So we can add those labels here. So we had a beaker containing water, which formed our water bath. We have our tripod and gauze. And simply, a Bunsen burner is represented by an arrow with the word heat over the top. Up here we have our crystallizing dish or evaporating dish or basin. We have our salt solution. And it does not necessarily have to be sodium chloride solution. It could be something like copper sulfate solution, or any other salt would do exactly the same thing. And a suitable explanation would look like this. So a gentle heating is used to evaporate the water. The solid salt is left in the evaporating dish or crystallizing dish to cool and crystallize. Time to see what you've learnt with a quiz. Question 1. What is the insoluble solid trapped in the filter paper? It's the residue. Question 2. What is the soluble solution that passes through the filter paper? That's the filtrate. Question 3. Which separating technique should I use to separate rocks from sugar? Well, rocks are insoluble in water, they do not dissolve, whereas sugar is a soluble substance that will dissolve. Therefore, we can use the process of filtration, where the rocks will get trapped in the filter paper, whereas the sugar can dissolve in water and pass through the filter paper. Which separating technique should I use to separate magnesium chloride from water? Well, magnesium chloride is a salt and dissolves in water. Therefore, we can simply evaporate the water to leave behind the magnesium chloride through the process of crystallization. And finally, what is meant by the term insoluble? Well, we've used that term a lot in this lesson. It means it does not dissolve. For example, sand does not dissolve in water, it is insoluble. The next lesson in this unit, we are looking at Lesson 3, Distillation. Thank you for listening to the GCSE Science Tutor. Please remember to like and subscribe to get further updates on lessons and tutorials.